Okay, so I have already included notes on the some of the basic information on the struts, and so this is the first part that I'm going to be testing in the process of diagnosing the issue on the airmatic system. Now, I've already described that there were several issues, and some I've already fixed, and some I'm in the process of fixing, and these are some of the notes to basically highlight what is that I had to do to fix the system. So this is basically the airmatic air compressor that I've taken out from the first Mercedes I showed, which has currently the front to airmatic suspension failure. And so I've taken the pump out, and what I've done is on this pump basically I have on this compressor I have replaced this piston ring, which basically seals the piston as it moves inside the cylinder and creates air compression, and that basically feeds to the valve assembly, and from there it goes to the airmatic struts and the air tank. So to replace this is quite simple. You basically take these two bolts out, and this whole unit lifts up, and underneath that there's a seal, and around the piston you basically put this ring and just assemble the unit again. There are plenty of videos available showing how to replace this ring. So if you look for a Webco repair video in YouTube, you'll probably find one that actually shows you how to replace this. It's very simple. So basically I've replaced that. I've replaced this ring, but the reason I've had to replace this ring is simply because I had a tear in the pipe that connects to, it's a rubber pipe which connects to the air inlet to the system, and basically that pipe connects to an air filter housing. It's a very small plastic housing which basically filters the air and feeds it to the air compressor, and what happened was the rubber had a tear in it. So instead of taking clean air through the filter, it was actually taking moist air from the from the tear in the pipe and feeding water inside the air compressor, and that basically caused the air compressor to run much longer, and it also damaged this ring as well. Now this ring is basically has a curve around the edges, and that's pretty normal. There's no oil in this compressor, so it's dry, and this ring has actually lasted more than 12 years, so it has served well, and it's not a big issue to actually replace this, mainly if it's failed because of the tear in the rubber pipe. And one of the ways to see how this ring has failed is if I turn it around, you can probably see where the edges are becoming a bit smaller and smaller in size, and that's where the air was escaping while the compression was being created. And if I go further, you can see it's a little bit more larger area of the curve. Okay, so I've replaced the ring, and the next thing I want to cover is basically what I had to do to test this air compressor. Once I'd replaced the ring, I wanted to test each aspect of this compressor to make sure that when I put it back in, it's going to be working perfectly fine. Now, before I do that, I'm just going to quickly show you a diagram from a Mercedes Mercedes document, and that it basically shows the air compressor down here. This is the valve assembly at the top, and this is the pipe that I basically mentioned where it had a tear, and that's the filter, and that basically connects to a pipe where it takes the air in, cleans it, sends it around this U-bend into the system. So you can see that's this part here. So basically, this diagram here outlines different aspects of the air compressor. Now, in order to test this, the very first thing I've had to do is there are two main electrical components that you can test on this. One is the solenoid valve, which is basically in here, and there's the connector for that, and you can feed it 12 volts, and that will basically operate the solenoid valve, and all it does is it basically changes the direction of the air. So when the compressor is running, when the solenoid kicks in, it basically, instead of pushing the air into the valve, it actually extracts it, and that allows the vehicle to be lowered. So so when the suspension lowers based on your speed and how the computer calculates, it extracts the air, and that happens via the solenoid valve, and basically pushes the air out. And when it pushes the air out, the idea is that it's also cleaning the air filter as well, because remember, the air is no longer coming in, it's actually going out. Hence the reason Mercedes have suggested not to actually change the filter. But to be honest, once I've seen the filter, and when I took this out, I just couldn't believe that wasn't part of the service, because I think that filter should be changed every few years, because it was well clogged, regardless of what the compressor does to send the air back to clean it up. So basically, that's the solenoid valve. So there are two pins in here, and you simply give it 12 volt, and you'll hear a click, and that basically tells you whether the solenoid valve is working or not. And the second one is basically here. You need to give it 12 volts. Now, I created a separate connector, so I didn't have to chop these cables, and I put that inside, and I made some decent quality connector. As a matter of fact, I'll show you that in just a moment. Because when the compressor kicks in, and let's say you are using a 12 volt car battery to power this, there's a decent amount of kick to it. So if you're just holding wires to it, it will not allow you to test the compressor properly. So create a good connector, and basically plug it in, feed it via the battery, and what you should find is there should be air coming out of this outlet. And before changing this ring, basically I could put my thumb on this and block the air. That's how weak the compression was. But once I had replaced the ring, the compression was so good, so the air supply was so good that there was no way I could stop the air from coming out. So it showed me that there is a difference. Obviously, there are better ways to measure that. You could put some sort of meter there, and so some sort of gauge there, and work out how much pressure is being generated, etc. But I could clearly see there's a huge difference, and that was good enough for me. So that's basically after the ring. So I've explained that the two types of controls that you have to you can test the electronic components is the solenoid valve and the motor. And just before I show you what kind of connector I've created for this, let me just also give you a little bit of information of where you're going to find this compressor. So this compressor is going to be behind the bumper, and basically it's got the valve assembly on top, and from there these nylon pipes basically go to individual struts, and the car's ECU basically tells the system to provide air supply to this air tank, and the actual regulation of how much air goes in and stuff then is measured from the sensors on each of the struts, and the ECU basically balances the car. That's how the system works. So basically the purpose of this airmatic compressor is simply to create enough air supply for the airmatic suspensions to work. So I'm just going to pause the video, and I'll show you quickly what type of connectors I've created to plug into this, and and then I'll move on to the next component I've tested. So I'm just going to pause the video. Okay, so in order to test the air compressor, I had to use the car battery, because if you don't have enough amps, you will not be able to run the motor to generate enough compression and to be able to test. So you do need to use a car battery or something with decent amount of amps, so that this compressor will run. And so the cable I made was, obviously you've got these standard basically connectors for the battery connectors, and I got myself some good quality cable. I put a fuse in there as well, just in case there was an overload or the motor was short-circuited, just for safety. And also I knew that I could reuse this in the future. And what I've done is I used a normal connector, which you would use to basically maybe use it for the stereo wiring and stuff. And then I used a heat shrink wire shield, this rubber one, and basically put it on that and isolated it, so that when I actually put it inside this socket here and the motor cranks, it doesn't actually end up short-circuiting the lead. So this one is the positive one I made, and the other one is the negative. And so you can probably see it now here. So that's basically, so, and once you actually plug these in, they're quite sturdy. So when I connect it to the battery, they don't disconnect, and that allows me to test the air compressor. So now that I've explained all the things that I did on to sort out the air compressor, I'm going to move on to the valve assembly and share some of the notes on that. So thank you for watching this video, and hope it was of some use. Thank you.